Today we're going to be covering the trigonometry functions sine, cosine, and tangent using the Sherpa online classroom in 5 minutes or less. So let's look at the sine wave. On the y-axis, we go between 1 and -1, and on the x-axis we have the angle. As you can see, we cross 0 at 180 and 360, with our peaks at 90 degrees and 270 degrees. Now the way that we find the angle or the length from these is by going between the two. So say we go sine 90 degrees. On our graph, that comes up as 1. So sine 90 equals 1. Alternatively, we could use sine 180 and get 0. Now with the cos wave, this is almost identical, but instead of starting from 0, we start from 1. So cos 0 will equal 1, cos 180 will equal -1. And then cos 90 is 0, and cos 270 is 0. This is exactly the same as the sine wave, it's just been shifted by 90 degrees. Finally, we have the tangent. To understand how the tangent wave looks, you have to understand what an asymptote is. Let's draw the asymptotes on the graph. Now, an asymptote is a line in which the wave never touches, but it will get infinitely close to. I'll show you how that works in a second. So we start from 0, and as we get towards 90 degrees, it tends to infinity. Then from 90, we have -infinity, and at 270 degrees, we go up to infinity again. But remember, it never actually touches the asymptote. It just gets infinitely close to it. This is a bit of an odd concept, but if you put it into your calculator, say tan 180, you're going to get 0, because at 180 degrees, tan is 0. But if you put in tan, let's say 90, you're going to get an error, because it never actually equals 90 degrees. It gets infinitely close to it and tends towards infinity. As you can see here, we'll draw these little lines. A tan wave goes higher than 1. So if theta goes towards 90 degrees, then tan theta is going to go towards infinity. So that was a lot to cover, so let's contextualize this and go through some questions. To start with, let's take a sine wave, okay? And the first thing we're going to try and figure out is sine 30. Okay, so what we do is we go along the x-axis, which is the angle, to 30 degrees. We go up, and we see where that lands on the y-axis. In the case of 30 degrees, that's going to come to a half. Okay, but what happens when we want to do the inverse? So sine to the -1 of -1. Well, we go down to -1 on the y-axis and find where that hits on our x-axis, and that's 270 degrees. And there you have it. That's how we use the trigonometric functions. But as a bonus, let's go over one final piece of trigonometry, and that's Pythagoras' theorem, which is just a squared plus b squared, all square root, is equal to c. Now, if you remember our last video on trigonometry, a would be the adjacent, b would be the opposite, and c would be the hypotenuse. So let's give that a go. If I have a right-angled triangle with, say, 3 and 4 as our lengths on the sides, well, we take 3 squared plus 4 squared, 9 plus 16 equal to 25. So our hypotenuse squared equals 25, and then we square root that, so our hypotenuse becomes 5. And there we have it. We figured out the final length of the triangle, the hypotenuse, using Pythagoras' theorem. And that covers all of our content for today, so the bonus of Pythagoras' theorem and the trigonometric functions. That's all we have time for with today's video. But as always, if you want to learn more, visit Sherpa-online.com, the only place you should be going to find your own personal tutor to help you get ahead of your studies. You can pick from a whole range of tutors and see what others have to say about them. And then, when you found the right tutor for you, you can use a Sherpa online classroom, which we use today, to have online lessons with your tutors, where you can speak face-to-face no matter where you are in the world. That's Sherpa-online.com. Visit it today.